G'day. Today I'd like to talk about indices or powers and the first three laws that we use when working with them. Now I'd like to start by talking about the form of indices. This part here is called the base, and this part here is called the index or the power or the exponent. Now, these are usually called exponents in the US and index or indices in the UK. Now, this would be pronounced 2 cubed. And the 3 refers to how many times the number is multiplied by itself. So in this case it's 3 times, so that's 2 by 2 by 2. When we go left to right, 2 by 2 is 4, by 2 is 8. 2 cubed is 8. Let's have another example. I've changed the power to 4. Now this would be expressed as 2 to the power of 4 or 2 to the 4th power So it would be 2 times 2 times 2 times 2. You see 4 times. And this, of course, is 16. Let's have another example. This time I've changed the base to 3 and the power to 2. Now this is pronounced 3 squared. And it's simply 3 times 3, which is 9. Okay, I'll change the power again. I've got 3 to the 4th power, or 3 to the power of 4, which will be 3 times 3 times 3 times 3. Left to right, 9, 27, 81 is the answer. Now I'd like to explain the laws of indices. Now the first law is a to the m times a to the n equals a to the m plus n. For example, if I had 2 squared times 2 cubed, that would be 2 to the 2 plus 3 equals 2 to the 5 equals 32. If I were to follow the order of operations, then I do exponents first. So that would be 4 times 8 equals 32. But these laws of indices allow us not to follow the order of operations, or to use a kind of special rule to make things easier and quicker. This is perhaps made clearer if I write this out in full. 2 squared times 2 cubed. Well, you can easily see that that's 2 by itself 5 times, you see. And for another example, I'll use 3 squared by 3. And this would equal 3 to to the 2 plus, this 3 in fact has a 1 there. So this is 3 plus 1 equals 3 cubed equals 27. If I were to follow the order of operations, then this would be 9 by 3. For a third example, I'll say 2 squared times 2 cubed times 2. Again, there's a 1 there. Now in this case, we can just add all the indices. 2 to the 2 plus 3 plus 1 equals 2 to the 6th power equals 64. Example D. This doesn't have to be a number, it can be a variable, like x to the 4th power times x to the 5th power. Well, we can just add the indices to get x to the 9th power. Example E. Now, we cannot use the laws of indices here because we have a different base. To use the first law, we must have the same base and a multiplication sign. Well, we've got the multiplication sign, but we don't have the same base. So, here we have to follow the order of operations, which means this is 8 times 9, which of course is 72. Example F. Here I have the same base, but I don't have a multiplication sign, so I cannot use the first law here either. If I can't, then I must follow the order of operations, so that's 4 plus 8, isn't it? Equals 12. So just to repeat, we need the same base and a multiplication sign to use the first law of indices. Now I'd like to move on to the second law, which is a to the m divided by a to the n equals a to the m minus n. For example, 2 to the 5th power divided by 2 cubed would be 2 to the 5 minus 3 equals 2 squared equals 4. An easy way to look at this might be to say, well, 2 to the 5th power is 2 by 2 by 2 by 2 by 2 over 2 cubed. And then, of course, we can just cancel, can't we? There. And I'm left with 4. If I follow the order of operations, which I can also do if I want, this is 32 divided by 8. Example B. 3 cubed divided by 3. Well, this will be 3 to the 3 minus, and there's a 1 here, so it's 3 minus 1 equals 3 squared equals 9. If I were to follow the order of operations, this would be 27 divided by 3, which of course is 9. This doesn't have to be a number, it can be a variable. So we could have x to the 7th power divided by x to the 5th power. That will be x to the 7 minus 5 equals x squared. Here's a further example. Can I use the laws of indices? No, I can't, because it's not the same base. I've got a division sign, but it's not the same base. So here I just follow the order of operations, which would be 36 divided by 9 equals 4. Example E. Three to the 4th power minus 3 to the cubed. Here I have the same base, but I don't have a division sign. I've got a subtraction sign. I can't use the laws of indices. I'll use the order of operations to say 81 minus 27 equals 54. So here I must have the same base and a division sign in order to use the second law of indices. Move on to the third law, which is a to the m raised to the n. This is a power raised to a power equals a to the m times n, or just mn. For example, 2 squared raised to the 3rd power. Well, that will be 2 to the 2 times 3 equals 2 to the 6th power equals 64. For another example, 3 squared raised to the 3rd power equals 3 to the 2 times 3 equals 3 to the 6th power equals 729. Notice I say raised to the such and such power. As I told you, this is a power raised to a power. So I say 3 squared raised to the 3rd power. Another example, 2 to the 4th power raised to the 2nd power, or I could say 2 to the 4th power all squared, multiplied by 2 cubed. Well, here we do this operation first. So this would be 2 to the 8th power times 2 cubed equals 2 to the 8 plus 3 equals 2 to the 11th power equals 2048. If I were to not use the laws of indices and just follow the order of operations, then this would be 16 squared by 8, which is 256 by 8, but that equals 2048. Another example, 3 cubed raised to the 3rd power, or 3 cubed all cubed, divided by 3 to the 4th power raised to the 2nd power, or 3 to the 4th power all squared. Again, we do this operation first, okay? So we have 3 to the 9th power divided by 3 to the 8th power equals 3 to the 9 minus 8 equals 3. You can see how, in this example, the rules of indices make things a lot easier than if you were forced to follow the order of operations. Another example, 7 squared raised to the 3rd power, or all cubed, divided by 7 to the 4th power raised to the 2nd power, multiplied by 7 squared to the 2nd power. Now here we do this first, okay, so this is 7 to the 6th minus 8 plus 4. 6 minus 8 is 7 squared equals 49. As far as the order of operations goes, we have division and multiplication in the same line. We go left to right. You may have learnt in algebra that when you have AB quantity squared, then the solution to this is A squared B squared. Now, in the same way, when we have powers inside the brackets, say here, I have A squared B cubed quantity to the 4th power, then this A is to the 8th power, 2 by 4, and B is to the 12th power, 3 by 4. So it works the same way. To give you an example, let's say we have 2 squared, 3 cubed, 2 all squared. Then it's 2 to the 4th power times 3 to the 6th power. And that would equal 16 times 729, I think. And this answer is 11,664. If I do brackets first, I get 4 by 27 squared. It's 108 squared. And 108 squared Now I want to look at the 4th law, also known as the zero rule. Let's start by listing the powers of 2. We know that 2 to the 5th power is 32. 2 to the 4th power is 16. 2 cubed is 8. 2 squared is 4. 2 to the 1st power is 2. And 2 to the 0 equals 1. Now this is what this is about. In fact, anything to the 0 equals 1. 243 to the 0 equals 1. And we can work the zero rule in with the other rules of indices. So if we have, say, 2 to the 4th power by 2 to the 0. Well, that will be 2 to the 4 plus 0 equals 2 to the 4th power equals 16. Actually, we're just multiplying by 1. 16 by 1. Similarly, if I had 2 to the 5th power divided by 2 to the 0, well, that would be 2 to the 5 minus 0 equals 2 to the 5 equals 32. But this is simply 32 divided by 1. Last example is 4 cubed raised to the 0. And because the whole expression is raised to the 0, the answer is 1. On my website, I have a worksheet you can download, Indices Worksheet 1, which gives you some practice exercises in laws 1 to 4. In a further video, I can correct that worksheet.